Hello and welcome to Spectra Education. I am Dr. Raisar Panja. We have started discussion about the gradient of a scalar field. In the last video lecture, we have found out what is the expression for nabla, and we all know that it is I cap del del x plus j cap del del y plus k cap z. You should always remember this expression. Okay, so today we will just find out some applications of this concept of the gradient of a scalar field. So the first application you can see that using the concept of the gradient, we'll be able to find out the unit normal of a given surface. What do you mean by the unit normal of a given surface? Okay, for example, if we consider a plane surface, for example, this mobile, you can see this the plane surface, and if we ask to find out the normal of this plane surface, you can easily find out that at each and every point the normals are along the same direction, right? They are all parallel, because this is a plane surface. But in place of plane surface, if we take a curved surface, so I can think this could be the best example at present for me. Maybe the curved surface, this is not even surface or a plane surface. You'll find at each and every point, maybe at that point the normal is along this direction, at that point the normal is along this direction. So how could you find out for a particular point what is the direction of the normal at that point? Gradient will help you to find out the normal at that. So let's see what it means. That for example, if you take a Cartesian coordinate system, that is x, y and z, and let's say there is a curved surface like this one, a, b, c, d. This is a curved surface, and it is asked at the point P, find out the normal, not the normal but the unit normal. That means it asks to find out the unit vector of the normal. Okay, so let's say this is the normal direction. That means this is the perpendicular at the point P over this surface, and you have to find out along this direction what is the unit vector, basically n cap. So how could you find out that one? There is no difficulties to find out. You have to just find out the gradient of the given surface. So this surface, this is a surface, and it is represented by this equation phi xyz is equal to 0. You have to find out the gradient of phi at the given point P. That's all. If you do that one, you will get the result, and then it gives you the normal. This gives you the normal. But to find out the unit normal, as you want, let's say this is a vector is equal to gradient of phi at that. This is a vector. Let's say this is a vector. So how could you find out the unit vector of this a vector? It is nothing but the a vector by magnitude of a vector. So that means whatever you find out the gradient of phi at the point P and divided by the magnitude of gradient of phi at the point P, it gives you the unit vector along this direction. So let's take one example and it becomes very clear to you. So the example is that one surface element is given. You can find out the equation of the surface is given, z square is equal to x square minus y square, and you have to find out the unit normal at the point 1, -1 and 2. So for example, although this is not true surface according to the given equation, so here it is given as that z square is equal to x square minus y square. So let's say this is this surface, this is not true surface. This is not according to the given expression, but to make it clear, we have just drawn this one. Okay, so here let's say this point P, and as we all know that this surface is represented by phi xyz is equal to 0, but it is not written in this form. So we will rearrange this term. We will get that x square minus y square minus z square is equal to 0, and which is nothing but right now we can say this is phi xyz is equal to 0. So this is the equation of this given surface, where phi xyz, what is the phi xyz? Phi xyz is equal to basically x square minus y square minus. At the point P, you have to find out the normal first. What is the normal? Step 1, how to find out this normal? Step 1, first you have to find out the normal. Find the normal at P. And what is the steps for that one? What basically you have to do? have to basically find out that gradient of phi at the point P. Okay, so let's find out what is the gradient of phi here. So gradient means I cap del x plus j cap del y plus k cap del z. It will be operated on the phi. Phi means x square minus y square minus z square. Find out this one. So I cap del, when del s is operated on that one, as you all know how to find out the gradient, it gives you this 2x minus 0 plus j cap. When del y is operated on that one, it gives you 0 minus 2y 0, and for k cap it is 0 minus 0 minus 2. So basically gradient of phi is 2x I cap minus 2y j cap plus 2z. But you have to find out the gradient of phi at the point P. P means is 1 minus 1 and 2. So with 2 into 1 cap plus 2 into minus 1 j cap minus 2 into 2. So it is basically 2 I cap minus plus, that is 2 j cap minus 4. So this is the gradient of phi, and what this is, let's say this one. What is this one? This is the gradient of P. Let's say this is the direction, and you have to right now find out along this direction what is the unit vector. So unit vector is basically, as you all know, just we have just gradient of phi divided by magnitude of. What is the gradient of phi here? Gradient of phi is this one. Just write this one, 2y cap plus 2 cap k cap, and divided by the magnitude. Magnitude of a vector is nothing but the root over of the coefficient square of I cap, j cap and k cap, that is 2 square plus 2 square plus 4. This is gives you 2 I cap plus 2 cap k cap divided by root over of, this is 4, 8, 16. I think so. That is the answer. Okay, so let's move to the another application of the gradient of a scalar field. We can find out what is the directional derivative of a scalar field. What do you mean by the directional derivative? Okay, so let's move directly to a numerical problem, and from there we'll also generate the concept of the directional derivative of a scalar field. So here this problem, it is given here. You can find out, just go through this problem, find out the directional derivative of this scalar functional field, where at the point -1, 1 and 2, along which direction? This is the direction. So let's try to understand what does it mean. So this is a Cartesian coordinate system, x, y and z, and let's identify this point. This is along the x direction is a minus, and on the y direction is a plus, and let's say this point is P, which is 1, 1 and 2. At that point, along this direction, you have to find out the directional derivative of the given scalar. What does it mean? Let's try to understand. So from that point, there are several directions. There are infinite number of directions, right? And among all this direction, let's say this is the direction of 2 I cap plus j cap minus, and let's say this simply indicates the a vector. And among all these directions, there will be a direction of gradient of phi, along which the phi is increasing rapidly. And let us consider this direction is, let's say this is the gradient of phi. And what do you mean by the directional derivative? In short, I am writing dd, directional derivative of phi along the direction of a vector. It means the component of gradient of phi along a vector. Mathematically, we will just write that gradient of phi at the point P, which is dotted with the unit vector along this direction. This is the unit vector. Unit vector along which direction? The given direction. Okay. So basically, directional derivative of the given scalar field, what you have to find out? In step one, write down this one. It helps you a lot. In step one, first you have to find out the gradient of phi at the given point. Let's say this point is P. In step two, you have to find out what is the unit vector of the given direction. In step 3, you have to just make a dot product between the gradient of phi at the point P dotted with the n cap, and you will get the directional derivative of. Okay, so let's follow these steps and try to solve this equation. So step 1, as we have written, step 1, just find out the gradient of phi. So gradient of phi is basically simple I cap del del x plus j cap del del y plus k cap del del z, and the given function phi is equal to x y square z plus 4 square z. Okay, so if you solve that one, I cap, when del del x is operated on that whole terms, it gives you the first one is y square z, and the second one is 8x z plus j cap when operates on that one, it's give you 2xyz, and the second one is 0 if there is no y term, and also the k cap when it operates on that one, xy square, and there is 4x square z, that means it gives you 4 square 1. Okay, so now you have to find out in step 1 that the gradient of phi on the given point, that is -1, 1 and 2. You will find generally this is I cap. What is the y square? Y square is equal to 1, and z is basically 2, and this is 8 into -1 into 2, that is 16. Okay, j cap, and check the calculation, maybe certain mistakes will be there. You have to just check by yourself. So 2 into -1 into 1 into 2, that means it gives -4, and k cap, but it gives x is equal to -1, it's 1, so it is basically -1, and it gives. Okay, so it gives me that it is 14 cap, it's -4 cap, and it is 3. So first step completed, gradient of phi at the point P we found out. So let's move to the step 2. Step 2, you have to find out the n cap along the given direction, a vector is equal to 2I cap plus j cap minus. So what is the n cap right now? So n cap is equal, let's change the color. N cap is equal to a vector by magnitude of a vector. A vector is nothing but 2I cap plus cap, magnitude of this one is square plus square plus. Okay, so it is I cap plus cap divided by this, basically gives you 4 plus 5, 1, 6 root of. And the last and the final step to find out the directional derivative. Here we have to just find out gradient of phi point P dot with that n. What is the gradient of phi? It is minus cap plus 4 j cap plus 3 cap and dot 1 by root over of 6, you can think. Yeah, right, y cap cap, and I believe that you all know how to solve this dot product. 1 by root 6 as it is, it gives you minus 14 divided by 2, that is minus 28. I cap dot I cap is 1, then minus 4, and it gives you minus 3. What is 7? Minus of 5 by 6. So this is the directional derivative of phi xyz that point this direction. This is so simple, right? So just practice by yourself, take several problems. If you find any difficulties, let me know in the comment box. We'll meet again. And that's all from the gradient. There is not more than that. We'll just discuss the new topic is the divergence of the vector field, curl of the vector field in next week. That's all for the day. Meet again next. Okay, bye.